Welcome back, guys. So today we are now moving from our critical paths and activity analysis into a new area called maximum flow. So just to confuse you, now we go back to labeling the vertices with the letter rather than the edges, okay? And we look at today's lesson. It's all about what the maximum flow through the entire network is. So I just want to talk through this example first. Let's say that this was the network diagram of, let's say, the plumbing in somebody's home, and the pipes are the edges and the numbers are the maximum amount of water that could flow through that pipe at any given time. So you can see then from pipe S to A, so these might be different rooms, 3 litres, let's say 3 litres of water could pass through there at any time. But if we were going through the pipe S to C, you can see that 4 litres. So if the question asked you to calculate the maximum flow through this network, we have a few new names. We call the starting point the source where the it's where the water originates from, okay? So it's our source. And the end point is the sink, okay, where the water is traveling all to. So make sure you have that written in your books because that's important, just knowing which one's the source, which one's the sink. Now, if I want to know what the maximum possible flow is to get water from the source to the sink, you have to keep in mind that what's going to happen when we get from the source, the pipe that can carry 4 litres, and suddenly it now blocks off and only can carry 2 litres, it's going to slow down, or it'll have to spread out, okay, because we can't fit the full 4 litres into the pipe here that can only carry 2 litres. So ideally, what we would expect, you'd think, well, okay, if I need to find the maximum amount of water that could travel to vertice T here, which is our sink, wouldn't it just be 5 plus 2? Because 5 litres can come through this pipe and 2 litres can come from this pipe. So wouldn't you think that it would just be 7? So this is how we test that theory, okay? Because we can't assume that it is 7. So let's think about it this way. If I think about this, there's 3 real paths I could get from the source to the sink. I could travel along SABT, or I could travel SCT, or SCBT. They're the 3 different paths. Let's have a look at just SABT. Okay, so that's going from S to A to B to T. The maximum I can get in one of these pipes is 3. So I can't suddenly get 3 and then it go up to 5. If there's only 3 litres of water that can travel through this pipe, there's only going to be 3 litres along the next pipe here, which we have a maximum of. But that means there's only going to be 3 litres when you get to that final pipe. Even though it can hold 5, we're only going to be travelling 3 litres through that, because that's the maximum amount of water that could come through this particular path. So now let's have a look at one of the other routes. If I say change my colour, let's have a look at SCT. Well, the maximum amount, it's the smallest number along the pipe. The maximum amount you can see is going to be 2. Okay, because even though 4 can be travelled through the first one, 2 is the most that this path could handle in litres. So I'm only going to be using 2 litres along that flow there. So that was SCT. Now, if I pick a different colour, green, let's look along our final path to get from the source of the sink, SCBT. Well, what's the smallest number there? 2. Okay, so I'm going to be using the 2 here. I would use 2 along here, which correlates to not overflowing that pipe there, because this pipe can originally only hold 5. And if you look, I've used 3 up by going along the red, The water flowing through the red line has used 3 litres, and now the water flowing along the green line is using 2, which makes a total of 5. So I'm okay, I'm not busting the pipe. And then I'm going to be using the other 2 litres out of this one here. 2 of the litres were already used to go along the blue, but now I can hold 4, so I'm using the other 2 along my last path. So now what we say, the maximum flow is our 3 numbers gathered along our final vertices, final edges. So the 3 circled numbers that I have in total there gives me my maximum flow. So if I keep the colour going, so it would be the 2 from here, plussing with the 3, and then plussing with the 2, which gives me an answer of 7. So the maximum flow through this network is 7 litres. So I'll just rerun that last step there. It's always just a matter of any circled numbers that you have on those last edges that meet the sink, you add them all up. Okay, so the 2 plus the 3 plus the 2 gives me my maximum flow. Now it's not always going to be our original guess. We guessed 7 because the original number was 5 and a 2, so we said, well, it makes sense to be 7. But now you can see that if the pipes before towards the source are too small, you're not always going to reach the maximum amount possible at the end. You have to go through this for now, go through this way to check it. Okay, I want to have a look at this example now. I've taken this straight from your textbook in the examples section before our exercise, and let's talk through it. So I like it because it sort of starts to get a little bit harder as we go. So if we have a look at this network, they've said that A, B, C, D, and E are towns. The edges are roads between them, and the weights on the edges, so the numbers, are the maximum number of cars that can travel on that road every hour. So instead of litres in a pipe, or litres of water in a pipe, this time it's the number of cars that can travel along that road. So part A says that we need to find the maximum traffic flow just from A to E through town C. So all that's saying is all they want is one of the possible ways, A to E through town C. So all we need to do is see what the maximum possible water flow is along that route only. So taking what we just did, we look at the smallest pipe. I still always think about them as pipes, but the smallest possible way. Smallest amount of cars is 300. So I'm going to be using 300 along here, 300 along here, and then of course the 300 that was there. So the answer to A is just 300 cars. Okay, it's the maximum amount. It's the most that whole path can hold. Okay, so it's the smallest number. Alright, so that was A, pretty easy. Now let's look at B. Find the maximum traffic flow from A to E overall. So from the source to the sink overall. So now what they're saying, okay, include every other path possible as well. So if we now take the other path, A, do it a different colour, A, D, E is our other path that we have to look at. Okay, because remember, it looks like the maximum possible flow is going to be 800 plus 150. Okay, so 950. Now we know it's not going to be any more than that, but will it be exactly that? This is why we have to check and find the smallest pipe possible. So along that route, ADE, the smallest amount of cars that can get through is 150, which means we can only fit 150 from this one. So what that now tells us is that 150 cars is the maximum amount of cars along that route there, and thinking about what I just talked to you about before, to find the overall maximum flow, we add all the numbers circled on the last edges that meet the final vertex. So what have we got circled? On the last edges we have a 150 and we have a 300. So the maximum flow is 150 plus 300, which gives me 450. So the overall amount of cars that could possibly flow through that network and get to the sink is 450 cars. Okay, now let's look at C. C says a new road is being built to allow traffic from town D to town C, and this road can carry 500 cars per hour. So if I just clean up my network a little bit, I don't want to take out too much important information. I'll just add that 300 back in. So let's add this road that they're talking about in. It goes from town D to town C, so that's in that direction, and it can carry 500. So suddenly we have another possible route around this network. So the new possible route that we could get is A, D, C, E. So now we have added that, so that's part I done, we've added it. Now we need to find the maximum traffic flow from A to E overall. So what we do now is we say, okay, now I just add my 150 that was, actually I just circle that. Now I just need to find, okay, what's the maximum flow of this new path, and then once again add all the final numbers up, and that'll give me my maximum flow. So let's have a look. Along that new path, A, D, C to E, well, the smallest number's 500, okay? So if I take my 500, so I'm going to use the 500 here. What you're going to find though is you're going to go use this 500, but think, oh, hang on, I can't use that whole 500 that's there because I'm already using 150 previously, which we had circled. So 150 out of that 500 possible along that route was already used up by one path. So now what I have to do is think, okay, well that means that I have an extra, what do I have, 350 possible cars that I could use up on here. So now that is my smallest number. So instead of circling the 500 that was originally there, I can use 350 out of each of the others. And then 350 out of here. And again, I have to make sure that I'm not going over 800. 300's been already used, plus 350, well that's only giving me 650. So I'm not going over that 800 possible amount. So what that means is now if I want the overall maximum flow, so the maximum flow for that particular path was 350, but now if I want the overall maximum flow of the entire network, what do? Well, I add all of the circled numbers that are on any of those last edges that meet the end point. So what does that give me? It gives me 150 plus 300 plus 350. And that gives me the overall maximum flow to be 800 cars. Okay, so what I want you to do now is have a go at just some of the questions from the exercise. So we're going to leave the cuts part for next video, but the only ones I want you to have a go at for now is question 1, and I want you to give all of them a go, okay? So you're finding the maximum flow of the entire network. So on each one, make sure you write out the possible paths, all the possible ways to get to the end. Find the shortest pipe on each one, and then add all of the end edges together. See how you go.